Good morning students, welcome to your maths class. So, in our last class we have learned how to find out HCF and LCM using prime factorization. In today's class, we are going to learn, as I told you before also in the last class, that today we are going to learn a few facts about HCF and LCM. But before doing that, let us know how to find out the LCM of three given numbers. And see, we have taken the same numbers as we had taken for the HCF also. We have taken 14, 28 and 35. So, let's begin. So, what are we going to do? Same method, we are going to first find out the prime factors. So, first we are going to do the prime factorization method. Okay. We are going to find the prime factors of these numbers. So, first we have 14. Then we have 28 and then we have 35. Now, why did I take the same numbers? I have taken the same numbers so that it becomes easier for you all to compare and understand what is the difference in the methodology of finding out the HCF and the LCM. So, first of all, the prime factors, this part remains the same. We do the prime factorization simply. So, 14 is divisible by 2. 2 7 are 14. 7 1 is 7. So, our 14 becomes 2 into 7. Right? Next, we have 28, which is divisible by 2. So, 2 14 are 28. 2 7 are 14. 7 1 is 7. That means here we have 2 into 2 into 7. And for 35, we had what? 5 7 are 35, 7 1 are 7. Right? So, we have 5 into 7. So, these are the numbers that we have. Now, in HCF what we did? We took the common number, the common factor which was present in all the three of them. Right? But in LCM, in our last class, I told you what? That we take both the common factor and the uncommon factor as well. So, first let us start with the common factor. Okay, let us start with the common factor. So, 7 is common. 7 is common. So, 7 into. Now, 2 is here. Okay, 2 is here. 2 is here also. So, in two places we have got a 2. So, we are going to take 1, 2. Alright. 2 2's are there. So, from 2 the 2's, we have taken 1, 2. Since it is not there. Next, we have what? This one's both of it gone. Now, 1, 2 is left. Is there any 2 here? No. Is there any 2 here? No. So, this 2 will come. This one also taken. Right? See. Now, I know this might be confusing. Why? First, as many common times it will be there. For every common number, we will take only 1. Okay? For every time a factor is common, we are going to take only 1. So, 7 is common in all the three of them. We have taken 1. 2 is common in 2 of them. So, we have taken 1. This 2 is left all alone. It is not having any common. So, this one has also come. And last, we have this 5. So, here comes our 5. So, what will be the LCM? 7 2 ja 14. 14 2 ja 28. And 28 into 5 is 140. You will have to do it. Okay. So, this is our LCM. That is 140. How did we do it? We took the common numbers, we took the uncommon numbers, the common factors and the uncommon factors both. For every factor which is common, even for two numbers, we have taken only one common. Okay. So, 7 was common in all the three of them. So, 1 times 7. 2 is common. Once 2 is common is 2 of them. So, we have taken 1, 2. This 2 is not having any common. This has come. 5 is not having any common. This has also come. Clear, children? And then we have multiplied and we have got our LCM. So I hope this is very clear. There is no confusion. Okay, great. Now we will talk about the interesting facts of HCF and LCM. So let me just clear the board. Okay. So when we talk about those facts or interesting facts about HCF and LCM, the first one that will come to you is product of two numbers will be equal to the HCF into LCM. Now what do I mean by this? This is the most general rule of HCF and LCM, that whichever two numbers is given to you, the product of those two numbers will always be equal to the HCF and the LCM. The product of those two numbers will always be equal to the HCF and the LCM. Alright? Now, let's do an example. Okay, let's do an example. So, I'll take a easy example. In our last class, we have already taken, I guess, 12 and 16. So, let's do that. Okay. Two 6 ja, 2 3 ja, 2 8 ja, 2 4 ja, 2 ja. So this one we had what? This and this we have 1 2. This is the HCF. Okay, this is the HCF. This and this 2. This is there. So what is the HCF? HCF is 4. If we talk about the LCM, in our last class we have taken out the LCM of these two numbers. So we have 2 into 2 into 3 into 2 into 2 is equal to 48. Okay. Now let us see, according to the rule, what it says. 12 into 16 should be equal to 4 into 48. Right? 12 into 16 should be equal to 4 into 48. So let us first do 12 into 16. 6 2 ja 12, 1 carry, 6 1 ja 6, 7, 12. Okay, let me just rub this. Alright. Six 12 just 72, 12, 2, 9, 1. We have 192. Clear? Now let's do 48 into 4. 4 8 ja 32, 3 carry 4 4 ja 16, 17, 18, 19. This one also we have what? 92. Are they both equal? Yes, they are equal. So children, I hope this formula, this rule is very, very clear to you. Whenever the product of two given numbers will always be equal to the product of their HCF and LCM. Okay? The product of two given numbers will always be equal to the product of their HCF and their LCM. Clear, children? Okay. So this was fact number 1. Now, if we talk about fact number 2, I'll just keep on writing it point wise, okay? Next, we have the LCM, the HCF. First of all, let us take the HCF. Is always smaller than the given numbers, or it will be equal to the smallest of the given numbers. This is fact number 2. That is the HCF of the given numbers. Whenever we find out the HCF, we will always see that the HCF will either be smaller than the given numbers, or it will be equal to the smallest of the given number. Supposedly the 3 numbers are given, say 4, 6 and 9. So the HCF will either be less than all of these, that means it will be the smaller than 4, 6 and 9, or it will be equal to 4, because 4 is the smallest of these 3 numbers. Okay. So HCF will always be smaller than the given numbers, or it will be equal to the smallest number. Similarly, if we talk about LCM, LCM is just the opposite. LCM is just the opposite. LCM will always be greater than the given numbers, or it will be equal to the highest of the largest number that is given. Okay, so similarly, if we talk about 4, 6 and 9, the LCM of theirs will be greater than all the 3 of them. Yes, it will be greater than 9 also. Or it can be equal to 9. It will not be equal to 6. It will not be smaller than 9. 8 is not an option. 7 is not an option. Never. It will never come below the given options. Either it will always be more than the given numbers, or it can be equal to the highest of the given number. Okay. And point number 4 is that, point number 4, I'm not writing point number 3, that's quite long. I'll give it in the notes. Okay. So, point number 4 is that the HCF will always divide the LCM of the given numbers. The HCF will exactly divide the LCM. So the HCF becomes a factor of the LCM. Okay. So if for a given number you are taking out the HCF and the LCM, you will always see, like just now we got that 48 and 4, right? So 48 is also divisible by 4 or not? 4 1 ja 4, 8, 4 2 ja 8. See? So the LCM will always be divisible by the HCF for the given numbers. Okay. So children, I'll keep it here for today. I hope you all had fun learning and knowing about these interesting facts. So in our next class, we are going to move on with some more sums regarding this chapter. Thank you and have a great day and keep practicing maths.